Işık Volume 2'nin son konuşmacıları olarak Wilkinson Air Architects'ten köprü mimarisine getirdiği analitik çözümler ve stratejilerle dikkat çeken mimar James Marks ile Spears & Measure'dan 16 yıllık tecrübeye sahip mimar kökenli aydınlatma tasarımcısı Carrie Donahue Bremner, İngiltere'deki Twin Sails Köprüsü projesi hakkında sunumlarını paylaşmak üzere buradalar. Kendilerini sahneye davet ediyorum.
Thank you. Someone
Do we go outside?
What's that? Do you want to go on the side?
Just thought I was taller. So.
Thank you very much. Thank you to EM and to the PLD and Philips for inviting us here to speak tonight. James and myself are going to speak on the collaboration of civic structures, most specifically bridges. Through over a decade of work together, we've collaborated on a number of civic structures. We're going to quickly highlight a few of these and discuss the process of collaborative design. Before we move on to a more detailed look at our most recent completion, the Twin Sails Bridge Pool. Before we look at these couple of projects, I'd like to note the important initial decisions made by the design team and the client progressing into each of the projects that we have personally collaborated on. First, the decision to create an iconic structure. The client, by hiring a team who aspired to deliver such a project, and the team by delivering conceptually on that decision. The second decision was to proceed with an integrated design, an approach with all the designers intertwining their work for a coordinated outcome from start to finish. And lastly, to reveal an ulterior image for the structures after dark. These three decisions provided the foundation for social engagement with the structure and the community taking ownership of it.
So before we talk about this bridge, we'd like to put this bridge really into the context of some of our other work. All of the images that we're going to show you are bridges where the lighting has been designed by Spears & Major as a specialist designer, or by me as the bridge architect. So we'll start by quickly flicking through some examples of these bridges just to set the scene and give you a taster of this work. What I love about my job, because I'm a specialist bridge designer, not buildings on the whole, is the variation in the projects in terms of the appearance and the scale. This slide shows the variety of different footbridges that I've delivered over the years. This is one of the smallest bridges I've ever worked on. You can't see it yet, but it's the Royal Ballet School Bridge in Covent Garden, built to link the ballet school with the Royal Opera House across a narrow urban street. Spears & Major were the lighting designer. Do you want to talk?
The really interesting thing about this project for us, in terms of the client wanting, an aspirational project, is that the link is only 9 meters wide. So the creation of a bridge in this location could have been quite a kind of simple outcome. But Wilkinson Air took it to quite a different level with their architectural design, and obviously we wanted to integrate within that design without adding an extra layer. But by day, the bridge has a life of its own with the way the daylight moves over the structure, and by night we wanted to kind of give it its own impression, but integrating so that we didn't impact it really by day. So in the corners there's a very delicate recessed acrylic backlit with LEDs, so that it just reinforces the movement of the bridge by night.
So as the structures get longer and the spans become more onerous, you can see that the expression of the structure itself becomes more pronounced. This is a footbridge based on an inverted Fink truss that we each completed a couple of years ago. And again, by night, what's interesting about this bridge, we've only lit the inside of the vertical components of the design. So in elevation, the bridge almost turns itself inside out by night. It gives you this texture and this depth to the nighttime image of the bridge. This is the Gateshead Millennium Bridge again. What I hope you'll notice as we're flicking through these slides is that there's no distinction between what is the architecture and what is the engineering. And in addition, the lighting is also completely coordinated with the structure. So architecture, engineering, and lighting design are completely seamlessly integrated. And this is a theme that we're going to pick up on later. This is the Living Bridge at the University of Limerick in the Republic of Ireland. This bridge has a very fluid alignment, and the lighting simply picks up the planned curves both above and below the deck. As an architect, what I love about designing bridges is that you start with the big idea, the concept, and then you develop a structural form with the engineer. After that, you're straight into the little details. How does the handrail connect to the deck? How is the soffit of the bridge expressed? Does the deck touch the ground? All the design in between that architects normally complete for a building is largely irrelevant. There is no insulation or weatherproofing to worry about, and on the whole there is nothing that can't be seen or experienced. So for me, bridge design distills architecture down to its essence, and you only do the fun bits of design. Now we're moving up a scale. This slide shows the road bridges I've worked on. Something else I love about the work is the variety. So we started off showing you a 9-metre long bridge in Covent Garden, but I also worked on this bridge at the bottom of the page, which is the Sutong Crossing in China, which has a clear span of 1.1 kilometres, and when it was completed in 2007 was the longest bridge on the planet for a time. But we're talking about this bridge, which is the Twin Sails Bridge in Poole, which, on the scale of things, is quite a modest structure, but hopefully in the course of this talk we'll show you how it's a very successful example of the collaborative process between the different disciplines. So how should multidisciplinary teams work with each other, each with their own skills and agenda, to produce a single, beautifully coordinated project? To answer this, we're going to start by giving you some examples of how the design process should not work. So this slide shows a simplified design program for an unsuccessful design process. In this scenario, an architect is invited to develop a concept for a bridge. The client, who might have little or no grasp of structure, buys into the concept, lured by its visual aspects and often a render of a colourful lighting scheme. The architect is commissioned to develop the design, and only then is an engineer employed to make the design stand up. From my experience, this approach seems to be normal operating procedure for bridge procurement in the Middle East at the moment. And sadly, it's also becoming more common in the UK, with the Royal Institute of British Architects launching often unsuccessful bridge competitions. I'd like to reiterate that this is not how we think a bridge should be procured. An engineer needs to be involved from the outset because they understand the physical fundamentals of structures. Some architects don't. So the result of a program is a structure like this one. This is the Dubai Smile. It is unique, but there are sound physical reasons why nobody has developed a structure like this before, especially to carry a major highway several hundred meters over water. At first sight, the structure appears to be a suspension bridge, but the catenary is an inverted arch, and the arch isn't supported at its ends, but cantilevers from a position over the water. Sadly, there are more examples like this. This was a competition for a footbridge in Krakow, and this is the winner. You'll notice that the weakest part of the bridge, where the arch meets the underslung catenary, there is no support, so simply put, this bridge can't stand up. And here are two infamous examples from the UK. The first is the Weir Bridge in Sunderland. This is the competition-winning scheme. Although an engineer was involved at the outset of this design process, he was swayed by the architect's insistence that he didn't want to have backstay cables to transfer the loads from the mainstays that support the roadway. The result is undeniably dramatic, but completely inefficient and therefore gratuitously costly. The second image is the winner of the Neptune's Way footbridge competition in Glasgow. Having won the competition and been commissioned to develop the design, the engineers very quickly realised that the architect's vision could not be made to work, and as a result the project was abandoned and a design and build competition was relaunched for the same site several years later. And some of these badly conceived ideas actually get built. This slide shows some gratuitous use of arches. These structures are not form active, there is no uniformly distributed load on any of these arches, and some of them even carry no load at all. They're just used purely as aesthetic devices. All of these are examples of over-ambitious architects trying to establish unique icons for their clients. The results might be unusual, but they are visually confusing and misinformed. For these designers, the bridge is seen as a sculpture on a massive scale. The original purpose of the bridge, to cross an obstacle, is lost in the clamour to provide something visually arresting and attention-grabbing. Bridges are performing structural gymnastics to support themselves across the void. Designs have lost sight of their reason for being, and context becomes meaningless, and references to the environment being traversed are ignored or even considered irrelevant in the pursuit of a gimmicky object which demands attention. If we look to the United States, the reverse problem is true. In America, architects are commonly perceived by clients and engineers to add fluff to bridges. Architects are there to choose the colour of the paint or to apply some cladding, often pseudo-historic, but not to inform the design in any meaningful way. This programme represents a common American model for involving an architect in the design process. An engineer develops the design for a bridge. The engineer works alone to establish the span configuration, chooses the typology of the structure, its scale, its alignment, and in short, the whole structure is often predetermined before an architect or a lighting designer becomes involved. The result is that American bridge architects simply design balustrades, apply some cladding, or propose motifs and relief to the engineer's concrete. At this stage, it is too late to input into the fundamental spatial arrangements of the bridge. The value that an architect could have brought to the design process is lost. And for a lighting designer, it's even worse. They find themselves simply choosing light fittings to retrofit to the structure as an afterthought. So, how should lighting designers, architects and engineers work in harmony to produce a beautiful yet functional structure? In our experience, this is best achieved by close collaboration for the full design process. The design process is completely iterative, with each discipline reacting to and evolving their design ideas in concert. Each designer is respectful to the skills and experience that their counterpart has to offer, and every detail can be resolved such that it is both functional yet beautiful. The bridge and its finishes are designed as a homogeneous object and not as a superstructure with applied adornment. For the rest of this talk, we intend to demonstrate this process with our case study. For this project, the lighting designers, architects and engineers developed the project in parallel as a cohesive product from inception to completion. I'm going to start by giving you some background to the project. For those of you not from the UK, Poole Harbour is on the south coast of England. The harbour is said to be the largest natural harbour in the world, behind Sydney Harbour in Australia. It's a stunning natural habitat and an area of special scientific interest. The bridge crosses a tributary leading to a large bay to the north of the harbour itself. The city of Poole is located to the north of Poole Harbour. Adjacent to Poole and across the water is another town called Hamworthy. The majority of the residents of Hamworthy work and shop in Poole, and so a direct link is important to avoid a circuitous route around the north of Holes Bay, as indicated by the blue dashed line there. Holes Bay is cut off from the main body of water in Poole Harbour by this channel. The blue arrow denotes the location of the existing bridge, linking to a one-way system to the north and to an arterial route to the west through Hamworthy. The red arrow is the location chosen by the client for the new bridge. At the east end of the new crossing, the new bridge will link to the existing road network, and to the west, the bridge will link to land that will ultimately be developed and onto the arterial route through Hamworthy. Holes Bay is a popular mooring location for private yachts. It's also where Sunseeker motor yachts are manufactured and where the local lifeboat station is based. And as a result of this channel linking Holes Bay with Poole's Harbour is extremely busy, and the existing bridge opens once every hour, every day of the year. However, with populations increasing, the existing bridge has also become a bottleneck for road users, and when out of operation causes major access problems for the local residents. As a result, the client, the Borough of Poole, launched a competition for a new bridge in 2002. Following their success on the Gateshead Millennium Bridge, the same multidisciplinary team of Gifford, Wilkinson Air Architects and Spears & Major reassembled to enter the competition. As always, the first thing we did was to visit the site. What struck us was the horizontality of Holes Bay and Poole Harbour, and of Poole and its suburbs. There is very little man-made here to punctuate the horizon, and as such you get long-reaching views to the New Forest and to the Isles of Purbeck, both local national beauty spots. As a result, we felt that the bridge should be very low-lying and modest. It should have very little structure above the deck, and since the bridge will be down for most of the time, it should be calm, modest and discreet. Incidentally, this is not an approach taken by one of our competitors on an earlier competition for the same site. Before I show you the next slide, what you need to know is that the corporate logo for Poole Council, the client, is a dolphin. So here we have two dolphins rising out of the water to kiss each other above the bridge. This gimmick would be a permanent and highly visible blight on the horizon, and thankfully was unsuccessful. Having decided that the bridge should be as low-key as possible when shut, we now need to decide how it opened. The existing bridge is a bascule bridge. Twin leaves pivot open about a horizontal transverse axis, like the drawbridge on a castle. The client had expressed the preference for bascule technology based on the robustness of their existing structure. And as a design team, we were also drawn to this type of mechanism because it did not rely on large overhead lifting mechanisms to do lifting or retracting. Probably the most famous example of a twin-leaf bascule bridge is Tower Bridge in London. However, there is one issue with this type of mechanism. When both leaves are down, they act as horizontal cantilevers. In order for the cantilevers to take vehicular traffic, it's necessary to lock the opposing leaves together at mid-span over the water to avoid large deflections under heavy loads. More often than not, it is these remote locking mechanisms that fail rather than the opening mechanism itself. One way to avoid this problem is to use a single bascule leaf, which is twice the length of the dual system. The advantage of this arrangement is that the lifting leaf can be laid down onto the opposing abutment. There are no locking mechanisms and the bridge is held in place by gravity alone. The disadvantage is that for the same size of opening structure, the centre of gravity of the mass to be raised is further from the pivot point, so the bridge uses a lot more energy to mobilise it. For this reason, single-leaf bascules often tend to have very large structures, and this was visually not in keeping with our preference for a low-key and modest design. We then started to look for other opening geometries, remembering that the opening structure could have any form as long as we maintained a 19-metre wide navigation channel with infinite height above the water. We realised that if we cut the opening line between the two leaves on the diagonal, we could get the best of both worlds. Each leaf could extend to the opposing abutment for support to gain the same benefit as a bascule system. But also, the triangular shape would mean that the centre of gravity for the movable deck would remain near to the pivot, reducing the force required to open the bridge to approaching that of the double bascule system. So in this diagram you can see this more easily. The centre of gravity is near the pivot because of the tapering shape of the bridge deck. And this arrangement also leads to a very dramatic opening sequence. The quiet bridge is suddenly transformed into a piece of kinetic sculpture as large shards of tarmac are lifted through into the air. There's also an accidental visual connection to the vessels in Holes Bay. It's difficult to ignore the similarity between the opening bridge and these tacking racing yachts.
Thank you. I'm just going to go back for 1 second. When we approach the lighting design, our initial reflection is on the structural intent and the architectural image that's already been created, or in the process of being created by the architect and engineering team, reinforcing the identity, the shape and form of the structure in the first instance. Interestingly enough, the expression of the structure and form of a bridge often provides a glimpse and understanding of the structure which is not apparent by day. Many of the hard thought about details lie in shadow. Lie in shadow by day, but by night, with light and also reflection, appear more distinct. It's also important on many of these structures to detail the equipment as to not to impact the structure and image of the bridge. Always being about the lit effect of the bridge against the nighttime sky and in the environment, and not expressing any of the equipment. And then there's that little bit of extra, the magic, the moment of experience, which at nighttime seals the memory. And so to talk a little bit more in detail about Pool. The architect, as James has already said, initial impression of the bridge was a strong horizontality, and to keep the bridge flat against the horizon, and then there being a larger impact upon opening. So for us that was really important that the lighting design should tie in with that. So when we go into the detailing, the horizontality was the first element that we needed to focus on, because there was obviously, it's a bridge and road and pedestrian and cyclist bridge, so there were technical requirements that we needed to meet, regulations that were quite strict, and it meant that we couldn't do anything from a high level. We really needed to keep all the equipment quite low, and if at all possible within the architectural line. So it meant that we had to look at locating the statutory lighting from a very low level. So we achieved this by using luminaires that were detailed into the vehicle restraint system. It was a highly complex detail that was the details passed between architect, structural engineer, electrical engineer, and lighting designer at least a dozen times to achieve the detail properly. Because the detail in terms of the actual vehicle restraint system had to meet extremely high specifications, as well as the supports from the base. And the luminaires had to sit back and protect them. We also had to consider, in case of an accident, quick replacement of both the VRS system as well as the luminaires to provide safety as quickly as possible. So the luminaires were detailed in such a way that cabling, if there was an accident, the way the VRS restraint system buckles, and the cabling was run, the luminaires should only ever go out in banks of 2. So we ended up cabling up and over left and up and over right to allow limited cabling to be affected in case of an accident. And so this is the lit effect of that at night, keeping it all very low level, and again, not impacting on the horizon. This also benefits for the fact that currently the horizon by night is actually quite a dark environment.
So we decided to enhance the presence of the opening bridge by extending some carbon fibre booms from the tip of each opening leaf. In this way, the rather modest 20-metre opening span is transformed into something more significant as it opens, particularly at night, where a cluster of LEDs in the tip of each mast sweep through the sky. The result is that the bridge is the only structure to break the skyline in Poole, but only when it opens. For the 10 minutes or so of the opening sequence, Poole's skyline is transformed, visibly reminding residents of the maritime connection. And because the bridge opens on a regular schedule, its opening visibly marks the passing of time.
And in terms of lighting that for us, it was enhancing the elements that went upon opening, the underside of the sails of the bridge, and also extending as high as possible into the night sky for that kind of moment and impact of the opening. So there was equipment located on the piers to uplight the sails when open, and the edge of the, do you want to talk about that? The edge of the tip, the carbon fiber mast had an has an integrated lighting detail. So the carbon fiber mast actually flexes upon opening, but at nighttime there are recessed LEDs behind acrylic panels that have been detailed and cast into the carbon fiber along the length. And just prior to opening of the bridge, this element lights up and then lifts lit into position.
So, having established the concepts, we now have to make the whole thing work and hold together. Although the shape was inherently beneficial in terms of its centre of gravity, as I've explained, we still needed to reduce the weight as much as possible to minimise the energy of the bridge in use. The main road deck is a fabricated steel monocoque box, braced internally with diaphragms and stiffeners. All unnecessary material has been removed. This slide shows one of the opening leaves during construction. The footway deck, which you can see in grey alongside the untreated roadway deck, is even lighter still. It's cantilevered from the edge of the road deck, and the cantilever is expressed as a succession of tapered ribs at the underside of the deck, onto which we mount the lightweight aluminium decking system as the walkway for pedestrians. The footway tapers to a narrow edge so that the whole crossing is understood as a simple line trajectory across the water. And here we can see that arrangement in cross-section. The closed box shape at the centre, which gives the bridge its strength, with the more filigree footway extending sideways as cantilevers. We purposefully located the concrete bridge piers inboard towards the centre line of the bridge so that they would be deep in shadow and would not disrupt the trajectory of the deck edge. The deck edge is also angled upwards to catch the light so that in all weather conditions the bridge is understood as a simple ribbon of structure between abutments. You can see that the overall result is very successful. For a highway structure that has to take articulated lorries, the deck appears extremely slender and has minimal disruption on the context of the bay. Because this bridge opens, we had to treat the soffit of the bridge with the same care and attention as the elevation. Every piece of structure is therefore shaped to be both structurally efficient and visually refined. There is no architectural cladding on this bridge. Everything you see here is the primary steel structure, and nothing is superfluous.
For us, again, when we start talking about the structure of the bridge and the main box section and the ribs as they extend out to support the lightweight pedestrian deck on the edges, the ribs are quite expressive. And in a similar way to Gateshead all those years previous, it was quite an advantage for us to be able to light them. They continued with the idea of horizontality of the bridge. They allowed the structure to be expressed, and this is the one like as if is in shadow during the day, but is expressed at night. And it also enhances the impression of the bridge by the lit reflection at night. The luminaires that were used to do it were tucked beneath the deck, adjacent to the ribs, in a relatively complex detail, with all the conduit to allow for maintenance and access from above the deck. So the luminaires rotate on a pivot arm and can be accessed from above the deck for ease of maintenance.
Another issue we were determined to solve was that of the mechanical and electrical equipment on the bridge. There's a surprising amount of equipment required these days to ensure the safe operation of an opening bridge, and this slide shows the existing structure. As well as the opening systems, there's CCTV, audible sounders, tannoy systems for pedestrians, tannoy systems for the marine traffic, physical barriers for the highway and for the footway, and visible warning signals. And as you can see, these systems can all add up to a lot of visual clutter. On our bridge, all of these systems are located into 4 totems located at the edges of the opening leaves. By concentrating all mechanical and electrical systems into these elements, we were able to maintain a calm and uncluttered bridge deck. This slide shows these totems from one of the approaches to the crossing. Although highly visible for safety reasons, the restrained palette of perforated stainless steel and simple curved shape is in keeping with the refined aesthetic of the bridge. You can see how effective these totems are at accommodating all of the statutory and safety equipment for road users, pedestrians and marine users on the water. And as well as visual and audible sounders, CCTV and communication systems, the totems also contain physical barrier arms which drop down to close the bridge before it opens. Although, of course, once the bridge does start to open, it forms its own unambiguous visual barrier. For us, for this one element that actually breaks the horizontality,
we discussed a series of things, and the idea that the surface was perforated to allow light behind it, a soft light, not to be stark against the night sky, but to just give this element that actually does require an enormous amount of technical integration within it, a little bit of life against the night sky.
The other finishes on the bridge are kept extremely simple. We used aluminium and stainless steel throughout for their robust properties, and at the deck edge we wanted the pedestrian parapet to be as visually light as possible. We chose stainless steel tension wires as the infill material. These disappear in long views of the bridge, and the parapet system is inclined towards the pedestrians to give an enhanced sense of enclosure despite the visual porosity of the infill. The inclination also helps to discourage children from climbing up and over.
The next element in terms of the parapet was how to light the statutory lighting requirements for the pedestrians. And again, in having to keep with the low-level requirement, it seemed obvious to use the handrail in some ways. This project actually started back in 2002, and what we had asked at the time for continuous linear LED was near impossible at the time, but we figured by the time it was built 3 or 4 years later that that would be possible. 9 years later, it was possible, and we were able to achieve quite a nice integrated detail with LEDs to light the pedestrian deck in a relatively inobtrusive way. That is also, we're extremely conscious of not having any borrowed light back onto the water, limiting glare to the mariners, and just lighting the surface that really needed to be lit. And so that's achieved. And the handrail in itself actually does a tougher job, which we'll talk about in a second.
So between the footway and the roadway there's a further balustrade system, and this screen performs a number of functions. Made up of a series of flat steel plates, is imperforate in oblique views. And what this does, it has the effect of divorcing the pedestrian from the highway and making them turn their attention outwards to the sea. And this makes the crossing of the bridge a more pleasant experience for those on foot. The screen also prevents errant pedestrians from crossing onto the road to walk around the footway barrier, which has to close before the one on the roadway. And in addition, the screen conceals the highway crash barrier that Carrie's been talking about, and the lighting systems from view, and acts to reflect light onto the footway from a void beneath the road deck.
For us, the relationship of the art screen and the box section against the lightweight pedestrian deck also left an opportunity to, again, kind of express the architectural intent beneath the screen. So we uplit the screen. Previously, in concept design, it was a more open structure rather than a solid fin structure, but it still takes the light quite well, and the grille beneath it glows with a red glow, and the red within this section also is reflected in the water by the images at night. So it acts as a contrast between the two decks, kind of reinforcing the requirement that the job that the art screen is doing for protection by night. And so to the extra moment and the extra magic and the kind of extra layer that we decided in terms of the image at night. And we discussed with the client adding on top of the architectural image and design by James and his team to add a layer in terms of light animation that worked in line with the bridge's opening. Because for us, the magic of the bridge is in the way in which it opens. And there are many opening bridges, but the sails opening against each other and the triangulated leaves, for us it really is quite a special kind of moment in time. So we really wanted to kind of enhance that by night and make more of an event of it by the evening. So we discussed with them the integration of a kind of color change of light. Very specifically, actually, not a color change, not any color, any time, any moment of the year, you know, red for Christmas and purple for Easter, but just about the bridge itself. And so on impact and opening of the bridge would take on a slightly different effect, so that as the bridge, you have your standard evening, and as the bridge opens, or just prior to the bridge opening, and the leaves kind of begin to break apart from each other, that the light begins to change and roll down the deck. And then it would change back again just before. So as a pedestrian, you're kind of engulfed in a slightly different light and effect. So after you have all your statutory lighting and all the elements on the bridge, and also as part of the kind of opening sequence of events, what happens is the sail is underlit and the mast lights come on. And then as the bridge actually breaks open, sorry, that went a bit fast. The pedestrian deck changes to from white to red. This was an early concept image that also increased the impact of the opening by having light actually kind of flow from the break of the deck. But in development of the detail, it's quite a complex detail in terms of the loads it needs to take and the locking mechanisms. So after lots of discussion, it was something that nobody wanted to let go, but in the end we had to. And the bridge would turn from white to red. One of the early images, one of the early references for that was a kind of lava flow that would engulf you, and then there is the extension with the mast, which has been detailed in. So as the bridge moves up, the lighting simply changes from white to red, and hopefully there are a whole series of events that occur because the totems which do their job and the barriers come down, the lights flash, the pedestrians are told to stop, the barriers come down, the mast lights come on, the lights come off to light the sail, and then the red light starts as the bridge opens. And I think for us, kind of in conclusion, the composition of all of these elements, for us, is what made the nighttime image. It wasn't one specific piece, but certainly linking with all of the architectural intent and taking clues from the structural rib design and dealing with the opening of the bridge that was created by Wilkinson Eyre, and adding that level of impact upon opening. Created an iconic image and experience, both by day and by night, which increases the impact on the people's psychological connection with the bridge, which for us is really important. It allows people who live locally to take possession, and people who visit to capture the memory. These relationships we create with places we live and visit can't be taken lightly. You know, it's a social engagement which drives people's pride, their connection, and their interaction with where they live. They spark a social interest, communication, and ultimately aid in economic growth. In our current climate of web-based communication, the quick marking of a memory with a snapshot and a caption and posting it for all to see is a record of that engagement. These photos were all taken from one website where over the past 6 months, hundreds of visits, notes, memories of this place were marked by both day and night. And for us, that's quite valuable. Thank you very much.
Carrie and James, thank you very much. Sorusu olan var mı acaba? Yaşar hocam kaldırdı ama bir arkadan da sorayım, var mı arka taraflardan sorusu olan? Size vereceğim. Buyurun.
Ben çok teşekkür ediyorum size. Gayet güzel köprüler üzerine bir sunum yaptınız. Ve gerçekten ben mutlu oldum. Bu konferansa geldiğim için çok mutluyum. İyi ki gelmişim. Bu Twin Sails Bridge köprüsüyle ilgili bir soru soracağım. Ondan önce iki tane Yunus'un kafa kafaya gelmesiyle böyle bir temelden, referanstan başlayan köprünün başarısız olduğunu gördük. Şimdi bu köprü gerçekten büyük bir buluş var burada ve müthiş bir teknoloji var ve detaylar çok güzel. Benim merak ettiğim bu yelken şeklinde bu baskül köprünün çözümünü köprü tasarımcısı Mr. James'in buluşu mu bu? Yoksa mimar kimdi bilmiyorum. Belki James Bey mimardır, tam tanımıyorum kendisini. Gerçekten iyi bir buluş yapılmış ve yine mimar ve köprü tasarımcısı, strüktür mühendisi ve aydınlatmanın muhteşem bir birlikteliğini gördük. Bunu aydınlatmasını rica edeceğim, bunu belirtmesini. Bir de bu açıklık ne kadar, yani baskülün olduğu kısımdaki açıklık ne kadar, onu merak ettim.
Before you answer, I'm so sorry. Çok özür diliyorum değerli misafirlerimiz. Konferansımız henüz bitmedi. Dolayısıyla mekanımız ortak bir alan olduğu için hem ikram alanı hem konferans alanı. Rica edeceğiz sizlere, biraz daha sessiz olabilirsek çıkışlarımızda. Konferans bitiminde ışıkları açacağız, müziğimizi açacağız ve kokteyli başlatacağız. Çok teşekkür ediyorum nezaketinize ve hassasiyetinize.
So, to answer your question, what I hope we demonstrated was that throughout the presentation was that there is no line between what bit the engineer designed, what bit the architect designed, which bit was the lighting designer. Because this was a collaborative process from day one, we were all involved in the projects from the very first design session, it's difficult to say who originated the design. And in all honesty, on these bridges, the design evolves. It seems like such a simple thing, but it's an iterative process where the architect says, how about this? The engineer says, well, that's a good idea because this achieves this. And it's a process that bounces back and forward, which is precisely why it's extremely important, if you want to get a cohesive result like this, for all of the parties to be involved and appointed by the client in the design process from the beginning. In answer to your second question about the width of the navigation channel, it's 19 meters required with infinite height for the navigation of larger ships and yachts. And the actual gap between the two abutments with which can hold the piers, the opening mechanism is 20 meters clear. Okay, I think that answered both of your questions.
No other questions. Başka sorusu yok galiba, başka sorumuz. Carrie and James, thank you very much. James Marks'a ve Carrie'ye çok teşekkür ediyoruz. Başta tabii ki ana sponsorumuz Philips'e ve siz değerli katılımcılarımıza bu yoğun ilginizden ötürü çok teşekkür ediyoruz. Mimaride Işık konferanslar serisi devam edecek. Dolayısıyla bizleri takip etmeye devam edin diyoruz. İyi akşamlar, iyi eğlenceler.